The velocity of a particle at any instant of time is 10 meter per second. After 3 seconds, its velocity will be 16. Its velocity will become 16 meter per second. The velocity of the particle 2 seconds before the given instant would be. So to understand the question, let us first draw a rough figure and say the motion is being represented from A to B and then from B to C. Now let us say it is at this time, say t is equal to x seconds. It is at this time that the velocity of the body is 10 meter per second. And after 3 seconds, which means at this time t is equal to x plus 3 seconds. At this seconds, the velocity becomes 16 meter per second. The velocity of the particles 2 seconds before, which means we need to find, say if that is the position of the body at t is equal to x minus 2 seconds. Now we need to find the velocity of the body here at this point. Okay, so what we do is, first let us try to understand what quantity is that we need to find out first. See, we know for the motion along which path? For the motion along BC, what do we have? See, we know that this much of gap of time is 3 seconds. So time is 3 seconds for this gap. What is the value of u? U is given here as 10 meter per second. What is the value of v? V is given as 16 meter per seconds. In which case, what is v is equal to? V is equal to u plus 80. So 16 is equal to 10 plus a into 3, which means a is equal to 16 minus 10 by 3, which is basically 6 by 3, and therefore a is 2 meter per second square. Now let us see the motion from A to B. See, do we know the velocity of body at A? No. So let us call that as u. In which case, the next second equation of motion would be, first equation of motion would be v is equal to u plus 80. It is asked in the question 2 seconds before the given instant, which means it would be 2 seconds duration here. So t is 2 seconds. What is the value of a? We just found it out to be 2 meter per second. What is the value of u? We need to find out. What is the value of v? We know that the v is here 10 meter per second, which means 10 is equal to u plus 80. So 10 is equal to u plus 2 into 2, which implies 10 is equal to u plus 4, and therefore u is equal to 10 minus 4, which is basically 6 meter per second. So the correct option is option A. A particle moving with uniform acceleration has a velocity of 6 meter per second at a distance 5 meter from the initial position. After moving another 7 meter, the velocity becomes 8 meter per second. The initial velocity of the body is. So first let us visualize the equation. So let us say the body starts from position A, it moves till position C, and an intermediate position is B. According to the question, at a distance 5 meter, so if AB is 5 meters, then the velocity at B is equal to 6 meter per second. So I can say that VB is 6 meter per second. Later, after moving another 5 meter, which means this much distance, BC is 7 meters. After moving another 7 meters, the velocity becomes 8 meter per second. So VC is 8 meter per second. Now, for the motion along AB, for the motion along AB, we can write the equation as v square is equal to u square plus 2as. Now what will be the final velocity? The final velocity will be vb. So vb square is equal to initial velocity. Now initial velocity here is not 0 because the body is never set to be at rest, which means it possesses some amount of initial velocity. Let us call that velocity as u or ua, or maybe just u. So it's u square plus 2 times a times s. How much is s? S is 5 meter. So what do we get the first equation as? We get the first equation as, how much is vb square? Vb is given as 6 meter per second square, so that becomes 36 is equal to u square plus 2 times 5 is 10, so we get 10a. Now for the second portion of the motion, which is for the motion along BC. For the motion along BC, we can again write the same equation, which is v square is equal to u square plus 2as. Now what is v here? V is velocity at c, so this becomes vc square is equal to u square. Now u square here would vary. Why? Because here the velocity, the body is moving from B to C, in which case u would be vb. So we can replace u as, we can replace u with vb square plus 2 into a into, how much would be s? S would be the distance between B and C, which is 7 meters. Now, so this will give us the equation vc square, which is 64, is equal to vb square, which is 36, plus 2 into 7 is 14, 14a. So 64 minus 36 is equal to 14a. We know that 64 minus 36 is 28, so 28 is equal to 14a, in which case a is equal to 2 meter per second square. Now if a is equal to 2 meter per second square, we can use this information over here with this equation. What do we get out of it? So we get 36 is equal to u square plus 10 into a is 2. So we get 36 is equal to u square plus 20, which means u square is equal to 36 minus 20 is 16. So u is 4 meter per second. Well, ideally the question coming to mind shouldn't be using plus or minus 4 meter per second. Yes, you should be using u is equal to plus or minus 4 meter per second. But what happens here is, since the motion is along the positive x-axis, the velocity here has not changed. It has not mentioned that the body is turning its position at any point, which means the velocity vector will also have the same direction, and therefore we can take positive 4 meter per second to be the correct answer. In which case the correct option would be option B, that is 4 meter per second. A particle has initial velocity of 2i plus 3j and acceleration of 0.3i plus 0.2j. The magnitude of velocity after 10 seconds would be. So this is a very typical application of equations of motion, but the only difference is that we've been given the vector notation instead of the direct values. So just to make sure that students get the concept clear, I'll just write down the question in the form of vector notation. So what we have is initial velocity. So vector u is given to be 2i cap plus 3j cap. What else is given? Acceleration is given as 0.3 I cap plus zero point 0.2 j cap, and time is given to be 10 seconds. Well, I would say the question is actually incomplete because the unit should have been mentioned. So it's 2i plus 3j meter per second, and acceleration should be meter per second square because all the units are given in meter per second. Apologies for the incomplete question. Okay, so moving on further. So what will be the equation of motion when in the vector notation? It will be vector v is equal to vector u plus vector a into t. What is given vector u? Vector u is given as 2i cap plus 3j cap. So this is vector u plus what is vector a? Vector a is given as 0.3 I cap plus 0.2 j cap. What is t? T is given as 10 seconds. So this would further be equal to 2 I cap plus 3 j cap plus 10 into 0.3 is 3 I cap plus 10 into 0.2 is 2 j cap. So this later would be equal to 2i plus 3i, or 2i cap plus 3i cap plus 3j cap plus 2j cap. So this would be equal to 5 I cap plus 5 j cap. So vector v is 5 I cap plus 5 j cap. What is being asked? Are we being asked to find out the velocity vector? No, we've been asked to find out the magnitude of velocity vector. So again, if a vector, say for example, if a vector r is given as rx I cap plus rx j cap vector r. So what is modulus of vector r, or magnitude of vector r, is equal to root of rx square plus ry square. What is the given vector here? Vector v is given as 5 I cap plus 5 j cap, which means modulus of vector v would be equal to root of 5 square plus 5 square, which is equal to root of 2 into 5 square, which is equal to root 2 into root 5 square. Therefore is equal to root 2 into 5, or 5 root 2, which makes the correct answer as option P, 5 root 2 meter per second. The initial velocity of a particle is u, and the acceleration f is given by at square. Its velocity at time t is given by. See, there are many questions which come in this format, and it's almost all of them have the same logic, and that's the primary reason why I have not taken similar questions like this. So let me just try to tell you how to do this question. It's a very simple question, and the only point I feel here is different, or say is tricky, is that they have exchanged the commonly used notation a for acceleration with f. This is all what they have done. So let us say acceleration, right? Acceleration is nothing but rate of change of velocity, right? So instead of using a is equal to dv by dt, what we should be doing here is use dv by dt is equal to f as given in the question, right? So what is f? F is given as dv by dt. Not just that, what we also have is the velocity, the expression for acceleration given as at square. That's it, we're done with the question. Now dv by dt is equal to at square, in which case what is dv is equal to, you cross multiply dt over here, So that becomes 8t square times dt. This is in the variable separable form, in which case dv is equal to 8t square dt can be integrated on both the sides. Now see, when we integrate, we need to have the limits. See, what is dv, or change in velocity, which means the variable there is velocity. What is the variable on the right hand side? It is dt, which is basically time. Now how will the velocity vary? The velocity will vary from the initial velocity to the final velocity. What is the initial velocity? The initial velocity is u. What is the final velocity? It is v, which means the velocity will vary from lower limit u to final limit v. How will the time vary? The time will vary from the time of starting time of observation, which is basically t is equal to 0, to any time t is equal to t at any instant of time t, which means the lower limit of time will be 0 and upper limit for time would be t. Now the integration is straightforward task. What is integral of dv? Integral of dv is v, and the v will vary from u to v. What is the integral of 8t square? A is a constant. Integral of t square is t cube upon 3, varying from 0 to t, which means upper limit minus lower limit v minus u is equal to a into t cube by 3 minus 0 cube by 3, which further will be equal to v minus u is equal to a into t cube by 3. Therefore, we can say that v is equal to u plus a t cube by 3. So this is the required relationship, in which case the correct option is option 2. And you should always keep this in mind that again here a is not equal to the acceleration. A is given as a different constant. It is not the usual notation that is used to describe acceleration. So the point why I highlighted this after concluding the solution is that if in case you get a question for further manipulation of the algebraic expression, you should keep this in mind that a is not equal to the acceleration. It's a constant. The position of a particle moving in the xy plane at any time t is given by x is equal to 3t square minus 6t and y is equal to t square minus 2t. Identify the correct statement from the following. Velocity of the particle at t is equal to 0, t is equal to 1, is 0, 1 or 2. Okay, so very good question, because this connects the equations of motion in a two-dimensional plane. Let's start solving this question by writing down the given equation. So what is given? X is given to be 3t square minus 60 and y is given as t square minus 2t. See, now what we need to understand is we've been given displacement. In both the x direction as well as the y direction. Now we know that the rate of change of displacement is nothing but velocity, which means dx by dt is also velocity and dy by dt is also velocity. But then what is dx by dt? Dx by dt is velocity in the x direction, and what is dy by dt is velocity in the y direction. So Vx would be equal to d by dt of 3t square minus 60 and dy by dt will be equal to d by dt of t square minus 2t. What is Vx is equal to? 60 minus 6, and what is Vy is equal to 2t minus 2. Now we've been asked to find out the correct statement at t is equal to 0, at t is equal to 0, t is equal to 0, t is equal to 1 and t equal to 1. So we need to substitute Vx at t is equal to 0 first. So what do we get? We get 6 into 0 minus 6 and Vy is equal to 2 into 0 minus 2. in which case Vx is equal to minus 6 and Vy is equal to minus 2. Now let us bring the concept of resolution of forces. See, if a force or if a vector r is inclined at an angle theta with the horizontal, then we can resolve two components, Rx and Ry, in which case the magnitude of the resultant is equal to Rx square plus Ry square. Applying this equation, we can say that velocity will be equal to root of Vx square plus Vy square, which is basically root of 6 square plus 2 square, which doesn't suit the answer here, which means at t is equal to 0, the velocity is definitely not 0, right? So this is not equal to 0. Now let us see the case when t is equal to 1. So when t is equal to 1, Vx would be equal to 6 into 1 minus 6, which is equal to 0. Now Vy would be 2 into 1 minus 2, which again would be equal to 0, which means V will be equal to root of Vx square plus Vy square, which is equal to root of 0 plus 0. Therefore, V is equal to 0 at what time? At time is equal to 1. So which option says that? So velocity of the particle is at time t is equal to 1 is 0 meter per second. So the correct option is option C. An object is moving along the positive x-axis with a uniform acceleration of 4 meter per second square. At time t is equal to 2, x equal to 5 meter and v is equal to 3 meter per second. What will be the velocity at the... Okay, so there's a small mistake here. It should be at t is equal to 0. Okay, what will the velocity of the object at t is equal to 2 seconds? Okay, so it goes like this. Well, first of all, I would like to apologize for putting such a very easy question in the middle of the playlist. Should be coming in the early sections. Okay. Nevertheless, let's start solving the problem. So we have acceleration is equal to 4 meter per second square. Velocity, initial velocity u is equal to 3 meter per second. What will be the velocity of the object at t is equal to 2 seconds is the question. So straightforward question. What is v is equal to? V is equal to u plus at. So what is v at t is equal to 2 equal to u plus t is equal to 2, right? So what is u? U is 3 meter per second. A is given as 4 and time is given as 2. So this becomes 3 plus 4 into 2 is 8. So that is 11 meter per second is the velocity. So the correct option is option D. A particle moving with uniform acceleration has a velocity of 8 meter per second at a distance of 6 meter from the origin. After moving another 10 meters, then the velocity becomes 12 meter per second. The initial velocity is. So, as usual, let's start the question solution by drawing a rough diagram. So it goes like this. A particle with uniform acceleration, the velocity of 8 meter per second at a distance of 6 meter. So the body has traveled 6 meter. And at this point, the particle has a velocity of 8 meter per second at a distance of 6 meter from the origin. Okay. After moving another 10 meters, which means this distance is now 10 meters. And here the particle has a velocity of 12 meter per second, right? So here the velocity is 12 meter per second. Let me write these positions as A, B, and C. And let us call this as VA, VB, and VC. So we're asked to find out the initial velocity, which is basically VA. To simplify the calculations, let me use the notation U. In which case, for the motion along, for the motion along AB, we can say that V is equal to U plus 80. Sorry, we can say that V square is okay. See, students often ask me this question: how do we realize which equation has to be applied in which question? So for that doubt to be clarified, let me just solve this question using this equation: V is equal to U plus 80. See, if V is equal to U plus 80 is applied for the motion along AB, what is V? V is the final velocity, which is basically VB. What is U? Is the initial velocity V. Write it as U alone plus A. What is A? Is acceleration given? No. So acceleration will remain as A as a variable. Is time given? No. It will remain as t itself. Now we have a linear equation with three unknowns. We have two scenarios, which means we'll get two such equations. And now we have two equations to find three variables. Will we be able to solve it? No. So that's how you choose a different equation. Now, let's try choosing one more equation. So we have V square is equal to U square plus 2AS. So even if by mistake you chose this equation while solving the question, it really doesn't matter. Now in this equation we can say that V is equal to VB square is equal to U is U square plus 2 into acceleration is unknown, but S we know because it is 6 meters. So we have one equation which says VB square is equal to U square plus 12A. And what is VB? VB is given as 8. So 8 square is 64. So we have 64 is equal to U square plus 12A. That is marked as equation number 1. Now for the motion along AC, we can again apply the same equation. We get V square is equal to U square plus 2AS. What is V? Final velocity. What is final velocity? Velocity at the final position. What is the final position? It is C. What is the final velocity at final position? It is VC. So we have VC square is equal to, what is U? U is the initial velocity. What is the initial velocity? Velocity is the initial point. What is the initial point? The initial point is A. So the initial velocity is VA, which we are given as U plus 2 into 8. What is the distance covered? The distance covered is 10 meter, isn't it? No, the distance covered is not 10 meters because we're talking about the entire distance AC. So the AC entire distance is AB plus BC, which is basically 10 plus 6, which is 16 meters. In which case, this is into 16. What is VC? Velocity is at C, 12. So 12 square is 144. So here 144 is equal to, so that was U square. U square plus 16 into 2 is 32A. So let us mark as equation number 2. What was the first equation? We have 64 is equal to U square plus 12A. If you subtract these two equations, what do we get? 1, 4 minus 4 is 0, 14 minus 4 is 8. So 80 is equal to 20A, in which case A is equal to 4 meter per second square. If A is equal to 4 meter per second square, what is equation number 1? Equation number 1 says 64 is equal to U square plus 12A, in which case 64 is equal to U square plus 12 into A is 4 meter per second square. So we have 64 is equal to U square plus 48. So 64 minus 48 is equal to U square. So 16 is equal to U square, and therefore U is 4 meter per second, which makes the correct option as option 4. A body is moving with uniform acceleration cover 200 meters in the first 2 seconds and 220 meters in the next 4 seconds. The velocity after 7 seconds is. Okay. A relatively difficult question, I would say. So let us consider the motion diagrammatically. The body starts from A. It covers 200 meters, then reaches B, and it is at C. Now, say the velocity at u is velocity at A is u, velocity at B is vb, and velocity at C is vc. Distance AB is given to be 200 meters. Distance BC is given to be 220 meters. The time for the first travel is 2 seconds, and time for the rest is the 4 seconds. So the total time taken for this travel is 6 seconds. Right. So now let's start solving the question. So choosing the correct equation to frame. We have been given seconds, we've been given time, we've been given distance. So let us use that relation. So we have S is equal to ut plus half a t square. Let's call that as S1 is equal to ut1 plus half a t1 square. Since the uniform acceleration, a remains a alone. Okay. So what is S1? S1 is 200 is equal to, do we know the initial velocity? No, we don't. So let us term that as u. What is the time? Time is given as 2 plus half into what is the acceleration? We don't know. A into time is 2, so t square is 2 square, which means 200 is equal to 2u plus 2 square is 4, 4 by 2 is 2, so you get 2a. If you divide the whole equation by 2, you get 100 is equal to u plus a, which we shall mark as the first equation. Now, coming to the next equation. Let us consider the motion from A to C, the complete motion. So in this case, what we have is S is equal to ut plus half a t square. Now what is S? S would be S2. What is S2? Would be the complete distance, 200 plus, like this is this distance, 200 plus 220, so that is 420 meters. What is time? Time would be the complete time, 2 plus 4, which is basically 6 seconds. So S2 is 420, which is equal to ut plus half into a into t square. T is 6 seconds. So this becomes 420 is equal to 6u plus 2 square is, 6 square is 36. 6 square is 36. 36 by 2 is 18. So 18a. If you divide the entire equation by 6, what do you get? 70 is equal to u plus 3a. And we may mark this as equation number 2. Now we got two equations. Which all are they? U plus a is equal to 100 and u plus 3a is equal to 70. If you subtract these, so 3 minus a is, or say u minus u is 0, a minus 3a is equal to 100 minus 70, which means minus 2a is equal to 30. Therefore, a is equal to 30 by minus 2, which is minus 15 meter per second square. Now, since a is equal to minus 50 meter per second square, what can we say from this equation? That 100 is equal to u plus a. A is minus 15, which implies u will be equal to 100 plus 15. That is 115 meter per second. Moving further, what has been asked in the question? The question is to find out the velocity at t is equal to 7, which is basically given by u plus 80. What is u? We just found it out. It is 115 plus a. What is a? A is minus 15. What is t? T is said to be after 7 seconds. So t is 7, in which case what we get is 115 minus 15 to 7 is 105. Therefore, the answer becomes 10 meter per second. So the correct option becomes option A. Position of a particle moving with uniform acceleration in a straight line is given by x is equal to 0 meter at t is equal to 0 seconds. t is equal to 1, x equal to 4, and t is equal to 2, x equal to 10. Find the velocity, initial velocity. So given that at t is equal to 0, x is 4 meters, t is equal to 1 seconds, x is 10 meters, and at I'm sorry, I made a mistake here. It should be t is equal to 1 here, right? Okay. Okay, so we have one more value. T is equal to 0, x equal to 0, t is equal to 1, x equal to 4 meters, and t is equal to 2, x equal to 10 meters. Okay. We've been asked to find the velocity at t is equal to 0. Right. So, let us see. We know that s is equal to ut plus half a t square. Right. Now, let us say this is s1, s2, and s3. And corresponding, we have t1, t2, and t3. Which means s1 would be equal to u t1 plus half a t1 square. s2 would be equal to u t2 plus half a t2 square. s3 would be equal to u t3 plus half a t3 square. As we know that t1 is equal to 0, this term will become 0, this term will also become 0, and therefore s1 is also 0. That's given in the question. But t2 is 1 seconds. So here s2 is given to be 4 meter. So 4 meters would be equal to u into 1 second plus half into a into 1 square. So basically what we get is 4 is equal to u plus a by 2. So if I take the LCM and cross multiply, what we get is 8 is equal to 2u plus a. Let me mark this as equation number 1. What is S3? S3 is 10. What is T2? T3? T3 is 2. So 10 is equal to u into 2 plus half a into 2 square, which further means 10 is equal to 2u plus 2 square is 4, 4 by 2 is 2, so we get 2a. If we divide the entire equation by 2, what do we get? We get 5 is equal to u plus a. So this will be equation number 2. Let me write these two equations together. So we got 2u plus a is equal to 8 and u plus a is equal to 5. If we subtract the equations, what do we get? 2u minus u plus a minus a is equal to 8 minus 5. 2u minus u is u, a minus a is 0, 8 minus 5 is 3. So we get u is equal to 3 meter per second, which makes the correct answer as option C. The initial velocity of a particle is u and the acceleration f is given by at. Which of the following relations is true regarding velocity? We did a very similar question, so I think we just can directly jump into the solution. So acceleration is equal to f is given as at. What is acceleration? Acceleration is dv by dt. So we've been given that dv by dt is equal to at, which means dv is equal to at times dt. This equation is in the variable separable form and thus can be integrated. We know that at time t is equal to 0, the velocity is u. At time t is equal to instant t, the final velocity is v. So we have the limits as u comma v and limits for t as t comma 0 comma t, in which case the integral is v, varying from u to v is equal to a into t square by 2 varying from 0 to t, which means v minus u is equal to a into t square by 2 minus 0 square by 2. Further means that v is equal to u plus a t square by 2, or v is equal to u plus a t square into 1 by 2, which is 0.5, which makes the correct answer as option B. A relatively simple question, because we did a very similar question a couple of videos back, right? So see, that's the main logic here, to do similar questions and to become more experienced and thereby increasing the speed in solving the questions.